I'm going to discuss the basics of ProtoScript Lua and regular Pure Lua, when to use which version of it, and a little bit about some of the more uncommon things that you may see inside of the code that aren't Lua-like. So in this charts example, ProtoScript Lua begins with a preamble. In that preamble, each of these named arguments are directives. They're called NodeDirectives, and can be referenced in the script. So you can think of it like a preprocessor that sets some base constants for the script to use. And those constants are used in different ways within the ProtoScript engine. So for example, down here, you will see $node being used. And that's part of the preprocessor that takes the value of node here, which is PUI1, and does a replace with that value. So everything in the preamble can be used within the script as a node directive, as a $ variable. Some other things you may see are these at variables, which are called decorators. And those are used internally by the engine for some upcoming functionalities in code generation, and as hints to the engine for optimization and a few other things that only should be used if you plan on creating reusable nodes. So what do I mean by a reusable node? Down here, I've added two scripts which do exactly the same thing. One of them is written in Pure Lua, and the other one is written in ProtoScript using the NodeDirectives and decorators. In the Pure version, which is this, notice even in the Pure version, there are some things that won't change. You'll still have the preamble, and we'll discuss what that imports are over here in just a second. But you'll notice that there are no $ variables. There's no mention of var. There's no mention of method. This is Pure Lua, so you have function, you have local variables, and this node is called Lua2. Which is also set in the preamble. But instead of using $node, I am hard coding the symbol to an object called Lua2 explicitly. rather than using $node. So this is completely functional code, which now we'll look at the ProtoScript version of that. The only thing that changes is the symbol, because they have to be unique. But if we scroll up, we'll see that the code is basically functions the same, but looks a little bit different. Here I'm using a node directive in the preprocessor variables by using the $, node, rather than explicitly setting the symbol name and the variable name as what looks like a native Lua variable. You'll also notice that I'm using method here instead of function. And method actually is not a preprocessor variable from a node directive. This is actually built into the Lua distribution and engine that we're using to differentiate between class methods and free functions. There's also another one called action. So that is built into Lua, that is not into this engine, and it's not part of the preprocessor. The reason to use the node directive variables in this way, as shown in this script, are if you want to be able to reuse this node. So you come up with some functionality within this node script, and you want to be able to instantiate it multiple times, or to create a new node type. A node type is what shows over in the node tree. And the node type is script host Lua in this scenario. So if I scroll up to the top, you'll see that each node has a type, which is basically a parent type, and it also has a name. If I wanted to come up with a new place name for this node, which would be in its own place in this node tree over here, I will need to use this form of ProtoScript so that it can be instantiated multiple times. Node will automatically, $node will automatically be replaced by whatever the symbol was used during the creation of that node. And there will be no symbol conflicts. And it creates components which can be reused. So to basically see those two again, that's ProtoScript, Lua, and there's Pure Lua. Feel free to pause it if you need to see the differences, but it's pretty apparent. So these are some of the, inside of ProtoScript, Lua, some of the other decorators that you can use. So var becomes local, method becomes function, And $ variables are from the node directives, and they are replaced by the value from the preamble. Lower here in the ProtoScript class method decorators, there are a few different types of decorators that are used to send hints to the object system within ProtoScript VM, which tells it which objects basically can call and use different exposed functions within your ProtoScript. And it also has type decorators so that you understand when you're dealing with different value types or objects or native objects or pointers. Here you see signal being used. I'll get rid of this extra stuff. Also, this text editor will automatically conform to whatever size based on what's on the screen. So if I take that away, basically does that. So you can automatically resize it. Either way, these decorators are based on the environment document structure and lifecycle. So right now we are in a scene which has a flow, which is the canvas. And on that flow canvas, we have one or more nodes. Within that node, there is a script. And that script needs to respond to different events. And those events come in different ways. Some of the events come from transport, which is the play, stop, record, etc. And when those events come in, signals are sent to the script. Those signals are related to playing, pausing, which is not in there yet, but will be in there. Hitting the back or restart or previous button, recording, and stopping. There are other signals for when the app is put into the background, when it comes back into the foreground, and several other signals that are sent to the ProtoScript node so that it can respond to actions in the environment. This clock also calls loop within the ProtoScript node. Loop here has two variables, node outputs and node inputs, which represent the sockets or the socket values for those named sockets, as was shown in the previous videos. In the previous video, I showed how to take in data from node inputs, and in order to write data to a socket, you simply assign to node outputs with a key being the socket name and a value to that socket. And at the end of loop, it will automatically go out of whatever socket was mentioned. So in this case, out corresponds to that out. So if you want to create nodes that are reusable, you should just stick with the convention of using the values from the preamble, which creates node directives, which are the $ variables, which are preprocessor variables. So in the last example, we were moving around the output of that chart to the instrument view, which it already is, or back into the node. I'll play it. So briefly, with ProtoUI, you're able to design sort of like Swift UI, a declarative way of describing your interface. So I'm going to send that to the instrument view. So what you can see is that it's creating a VStack. First of all, it's creating a variable called body, which is decorated to show that it is a GUI. That's important in ProtoScript because it's evaluated in an event-driven way or in a polling way. And I'll go over that later. But put GUI next to whatever the body of your UI is going to be to give the ProtoScript engine a hint of the fact that it's going to be using a UI that works on the main thread. So there's 3 charts here being created. The first one is food chart. We give it a symbol called chart 0. We set some other properties. And this line chart is a built-in part of the ProtoUI library. So it's available to use. There's several other ones that we'll go over later in a very detailed post on all of the functions that are available and UI components that are available in ProtoUI. So you can see that they're separated by a comma. This entire VStack is basically creating an array, and you are telling it in which order to add these different UI components. And this is the container that it's going to be in, a VStack. And after that VStack is created, you can set a frame, you can set the width, etc., among other properties that you can set. After it is set into the body variable here, you send that into the built-in called screen, which creates a screen, which is the instrument view, which is what's shown in the instrument view. So right now that VStack looks like that. But we can also, just as an example, horizontally stack those. By changing it to an HStack. Where are we adding values? In the screen, which is this, uses this body. Which again is set up above in a declarative way. And within screen's loop function, we are adding data to each of those data sets. How does the signal part work as far as reading from the transport? Well, I want it when I hit the back button or previous or reset, whatever you want to call it. I want it to reset the chart data. So that is why here we have a method called screen on previous, which is a built-in. And whenever it receives that signal from transport, it will, for each of those charts, reset its data. So next, I'm going to go over a full example by building a scene which takes in brainwaves from a Muse headband and processes that data in some way. We're going to use alpha. We filter alpha brainwaves and make an object move up or down or change color, all within ProtoScript and a couple of nodes